This is section 6, derivative rules, example 7. So we added, we subtracted, we multiplied, now we're dividing. All right, and just like multiplication doesn't work out the way that you would think it would, if you did it separately, division doesn't either. So we're going to use our quotient rule. The quotient rule is this right here. Okay, and it looks complicated when you have all those functions in there. So here's what I want you to remember. The derivative is low d high minus high d low all over low low. Okay, and where high is the top equation and low is the bottom equation, and d means the derivative. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom times the bottom. Now, when you have subtraction, remember subtraction is not commutative, which means that the order does matter. It's very important that when you go to use this rule, you do it in the correct order. Okay, so let's go ahead and use this rule. So here's our low, and here's our high. So that means that y prime is low d high, so 3x minus 2, low, times the derivative of the high, which is 0, right, because it's constant. Oops. Minus high d low, so 5, times the derivative of the bottom, which is 3, all over low low, so that would be 3x minus 2 squared. All right, and I'm going to go ahead and simplify that. 0 times anything is 0, so that goes away, which means we just get negative 15 over 3x minus 2 squared. Let's do another one. Low d high minus high d low over low low. So low is 2x plus 1. D high is the derivative of the top, which is 4, minus high, which was 4x minus 3, d low, the derivative of the bottom, which is 2, all over low low, which is 2x plus 1 squared. And I'm going to go ahead and distribute. So we'll distribute that 4. We'll distribute the 2, and don't forget that it's negative 2, which gives us 8x plus 4 minus 8x plus 6. Those cancel, and we get 10 over 2x plus 1 squared. All right, another one. Low. So x squared plus 4x minus 2, d high, so negative 1, right, that's the derivative of the top, minus high d low, the high is negative x, the derivative of the bottom is 2x plus 4, and that's all over low low. So x squared plus 4x minus 2 squared. And we're going to distribute again. So we get negative x squared plus 4x, nope, not plus, minus, plus 2. This negative and this negative right here, that becomes a plus. So now I don't have to worry about the negative sign anymore. So we just end up with plus 2x squared plus 4x all over our denominator. And then we combine like terms. So 2x squared minus x squared is just x squared. Negative 4x plus 4x cancel, and then we have plus 2 all over x squared plus 4x minus 2 squared. And really, unless you're going to use these for some reason, which we'll actually do in the next problem, all you have to do is leave it like that. You don't need to simplify the denominator. because it's going to be pretty complicated looking anyway. All right, so in part D, it asks us to find the instantaneous rate of change. Oh no, what's an instantaneous rate of change? A derivative. That's all it is. So we're still taking the derivative of y with respect to x at x equals 1 when y equals this equation where x does not equal 3. Now, x cannot equal 3 because our domain is where x cannot equal, actually that should be a negative 3. Negative 3. Okay, because negative 3 plus 3 is 0 and you're not allowed to divide by 0. So, when we do this, we're going to take the derivative, and then once we find the derivative and have it simplified, we're going to plug in 1, because that's what we're trying to find. The derivative of y with respect to x at x equals 1. So, first we find y prime. Well, y prime is going to be low, d high, so x plus 3, and the derivative of the top is 2x plus 6, minus the top, which was x squared plus 6x plus 2, times the derivative of the bottom, which is just 1, all over the bottom squared. Now we distribute. When we distribute, we get x times 2x, which is 2x squared, x times 6, which is 6x, 2x times 3, which is also 6x, and 6 times 3, which is 18, minus the second one, right? So minus x squared, minus 6x minus 2, all over x plus 3 squared. And now we simplify, combine our like terms, and when we do, we end up with x squared plus 6x plus 16 all over x plus 3 squared. Now if we want to find the derivative at 1, we're going to find y prime of 1, which means we're going to take 1 and plug it into all of those x values. That's it. So if I have 1 squared, I just have 1. If I have 6 times 1, we just have 6 plus 16 all over 1 plus 3 is 4 squared. And then 16 plus 6 plus 1 is 20, what is that, 23 over 16.